Good morning. I am Pradeep Kumar. Today I will solve a numerical problem based on psychometry. The problem is the reading from a sling psychometer is 30 degree centigrade dry bulb temperature and 20 degree centigrade wet bulb temperature. The reading of barometer is 740 mm of Hg. Using steam table, determine dew point temperature, relative humidity phi, specific humidity omega, degree of saturation mu, vapor density or the water vapor density, that is rho b, enthalpy of moist air H, humid specific heat CPM, and the partial pressure of water vapor. First, we should know what is ceiling psychometer. Ceiling psychometer is an apparatus having both the thermometer, dry valve thermometer and wet valve thermometer, and with the help of ceiling psychometer we can measure the value of dry valve temperature and wet valve temperature. But before solving this problem, you should know first we have three temperature: the dry valve temperature, wet valve temperature, and dew point temperature. So corresponding to these temperature, if we read the value of pressure corresponding to these temperature, the corresponding to the dry valve temperature from steam table, we will read the saturation pressure, that is denoted by PS, and corresponding to the wet valve temperature, we will read PW from the steam table, and corresponding to the dew point temperature, we will read the partial pressure of water vapor from the steam table. The both side arrow represent that if we have the value of PS, then we can read the value of dry valve temperature from the table. If we have the value of PW, then we can read the value of wet valve temperature from the steam table. And if we have PV, then corresponding to the PV, we can read the dew point temperature from the steam table. So if the temperature is given, we can read pressure. If the pressure is given, we can read the temperature from the table. So now what is given? The dry valve temperature is given, dBT TD equals to 30 degree centigrade, and wet valve temperature is 20 degree centigrade, and barometric pressure is 740 mm of Hg. So now from the steam table at dry valve temperature 30 degree centigrade, so corresponding to the dry bulb temperature 30 degree centigrade, we can read the saturation pressure. PS equals to, I have already told you, PS equals to, the value of PS will be 0.4242 bar. This is from the steam table at temperature 30 degree centigrade. And at wet valve temperature 20 degree centigrade, we can read corresponding value PW, and PW is at 20 degree centigrade is 0.02337 bar. These two values are in bar from table, but the barometric pressure is given as mm of Hg. So we should convert this pressure in the same unit bar also. Or we can convert these value in mm of Hg also. But all the pressure should be in same unit. So we can convert the mm of Hg, because we know that 760 mm of Hg is 1.01325 bar, that is standard atmospheric pressure. So 1 mm of Hg is 1 by 760 into 1.01325 bar, and the 740 mm of Hg will be 740 divided by 760 into 1.01325 bar. The value of barometric pressure will be 0.986585 bar. And now from the Carrier's equation, we know that PV equals to this. Put all the values in this equation. The temperature will be in degree centigrade. We get the partial pressure of water vapor 0.0170 bar. This is the answer of the 8th part for this problem. We have to find out the partial pressure of water vapor. So partial pressure of water vapor will be 0.0170 bar. And if we get the partial pressure, then from the steam table at partial pressure PV equals to 0.0170 bar, we can read the temperature, and temperature corresponding to this pressure will be the dew point temperature. It is equals to 15 degrees centigrade. And now the relative humidity, we know that PV by PS, we have the value of PV this, PS this, and the relative humidity will be 0.40 or the 40%. And the specific humidity 0.622 PV by PV minus PV. Put the value of PV and PB, we get the specific humidity omega equals to 0.0109. The unit will be kg of water vapor per kg of dry air. And the degree of saturation, we have this formula. Put all these values, we have mu equals to 0.3902. And the vapor density rho v equals to omega into PV minus PV upon RAT. In this equation, the unit should be balanced. If we put Ra, characteristic gas constant for dry air, 287, then the pressure will be in Pascal. So put these values in bar and multiplied by 10 to the power 5, it becomes in Pascal. And the temperature Td should be in Kelvin. So temperature is given 30 degrees centigrade. So 30 plus 273, we have the vapor density 0.01215 kg per meter cube. And the enthalpy of moist air is this. Put all these values, temperature in degree centigrade, and specific humidity, we get the enthalpy 58.014 kilojoule per kg of dry air. And the humid specific heat is this. Put the value of omega, we have CPM 1.025 kilojoule per kg of dry air Kelvin. Thank you. In next class, I will explain some other problem of the moist air.